UTS. Okay, so in the name of God, the compassionate, the merciful, this is our fifth session, if I'm not mistaken, on Idris. Now I decided to leave section 5 to you guys yourselves because you're already familiar with monads. Daniel, if you need extra help, you know where to find it.
Right.
Yeah, and that where to find it should also pay attention. James.
Yep, I know where to find it.
Okay, very good. Yes. So now today I am going to teach you something that you will come to practice a lot in C++. When I teach you the C++ template metaprogramming, you'll see a lot of what I'm going to teach today. So this chapter of the book, as you can see, it's called Programming with First-Class Types, is motivated around the idea that we have told you that types are first-class citizens in Idris. Now let's see how that spans out. Now, so my take on that is that in the world of C++, for efficiency reasons, we would like to perform a lot of calculations with types, and so we have a lot of things that help us work out the exact type of let's say arguments or of the return values and all that of functions. Now, usually the functions do a good job, but because C++ people are always thirsty for every drop of efficiency, we would like to, when we have those pieces of information, we would like to use it further. We would like to use them further to further optimize our code by being as much as narrow as possible with the typing information, so that the compiler doesn't issue extra checks that need to be performed during the runtime, and we would like to help the compiler to know at the compile time the exact types that are going to be used in the runtime, and therefore free itself from the runtime overhead. So this is the entire mindset, a very short summary of the entire mindset of type level programming in C++, which has consequences that I will tell you in C++ TMP. Now, the book that I'm now sharing with you on the screen does not quite go into that. It has its own motivations, which are only a small fractions of the what I just told you. Now, what the book goes through is that, well, you have seen functions like this append, which takes two vectors and returns a vector. And in order to calculate the type of the return vector, it needs to perform some type level operations, right? Now, in this case, the type level in the operation itself is a value operation, so it's not a real operation on types themselves. So you kind of take the same type that you are you return the same type that you are taking as input here, right? And the extra work that you're doing is in the addition of two variables. Now, so we are now going to see things which you perform at a type level by which you will be calculating a type. Now, so just for ourselves to have a piece of terminology that we can communicate in, the book refers to these things as the type level functions. In short, those are functions that calculate types for you or operate at the type level. Now, so imagine the situation when you want to deal with polygons, and so one way to do that is that, okay, you would think that, okay, I'm in 2D, so that would be a pair of doubles, and because there are 3 vertices that my triangle is going to have, I'm going to nominate that as a vector of 3 pairs of doubles. That's pretty straightforward. But then, you want to be extra readable to your user, and therefore, you get to say that, okay, I'm going to abstract away this pair of doubles. This is the positions that I am going to have. And now look at this. Position is a type, and the value of that type is a pair of doubles. It's exactly as if you were in another language, say in Haskell, you were trying to introduce a variable or a function, right? You give it the type that it is of, and then you work out the value of it, right? There is no need for extra keywords, for example, for type synonyms, right? Now this is our first hit on types being the same as the types being first-class citizens of this language. I contrast that to Haskell, for example. Now then, so once you're armed with that, you can do things like this. You can say that, okay, now triangle is a vector of 3 positions, right? Now, we can take this one extra level ahead and begin to utilize the dependent typing. And here is one possibility for doing so. By the way, is my book readable enough?
Yeah.
Yes.
Right. Okay. Okay. Very good. Now, so then you would say, okay, what is a polygon? A polygon has n vertices in general, and so we need a variable or a parameter of type nat, right? So that polygon becomes a type, right? And so just like the previous definition, polygon is of type nat to type. It takes a nat, it returns a type, right? And how does it do that? Well, it takes that number of vertices, and it in return it says, okay, I am a vector of n positions, right? Now, once you are armed with that, you can take the definition of the triangle one step ahead, one extra step ahead, and you get to say that, okay, tri is a polygon of 3, right? Now, if you ask the compiler to give you the type of this thing, you will see that it says that sorry, it's a polygon of 3. Right. Now, let's see. Right. Now the thing, there's no much of let me take the. Maybe I should put it here. Okay. There's no much extra that the TDD can provide for you, but one thing in particular that is interesting is that if you try to expand the definition of try, what it will produce for you is this kind of set of 6 holes grouped into groups of two groups of pairs, right? Now that's because using the synonym mechanism that you have given to it, it knows that a polygon of 3 is a list of 3. Sorry, is a vector of 3 pairs of doubles. So now I think that even thus far you have seen some extra pieces of syntax which are in fact quite important when it comes to the distinction between Idris as an important as a dependently typed language and the others. First of them is that types are first-class citizens. You just, when you need to introduce a new type, you do that in exactly the same way that you do that for value level variables. The other thing is that you can have functions which produce types in exactly the same way that you have functions that produce non-type values, right? Now, so we would like to get back to an example that we saw in I think it was the first chapter. That was when I introduced you for the first time to the dependently typed programming of Idris. We had this rather strange function which would return a type based on the value of a parameter that it receives. So this function, string or int, takes a boolean and returns a type. And well, if it's false, then it returns a string. If it's true, it returns an int. Well, it doesn't return an int, it returns the type int. My apologies. Now, so on that basis, right, we can kind of utilize that piece of information and begin to develop dependent type programming per se. Now, so we can do this in both. Let's see. I can do live coding, or I can do. Let me show that to you in. Right. Where are we? Where are we? Okay. Let me. So now we would like to have a function that takes a boolean and it returns a value of a specific type that is kind of non-standard for languages that are not dependently typed. What this is saying is that the type that this returned value is going to be of depends on the value of this, of this is int thing. Daniel, is that something you can digest?
Sorry, are you still sharing the book, or are you on the editor right now?
Oh, my apologies. I was showing my let me see. I need to. Thank you for reminding me about this.
Yeah, I was getting a little curious there.
Right. Can you see my Visual Studio now?
Yes, now I can.
Okay, very good. Now, so right, I have to repeat this part. So now we have a function that, based on a on a parameter that is passed to it, based on an argument that is passed to it, it decides on the type also of the returned value.
Yeah.
Right. So you see
Depending
that
on
this
how
is a
that
type.
evaluates. Yes.
Yeah, this is a type, but that type depends on the value of this int parameter. Right. That's the gist of, you know, dependently typed program. Now let's try to do our usual TDD on it. So we add clause, we save, and then we case split. Right. Now, as you can see, and then we save. So Idris knows that, okay, the set of possibilities here are false and true, and you know, so based on that, it knows. Maybe I should do something else first. So you see, when you can that dependency of the value of the type on the value, you can also see here when you scroll, when you hover on the whole. So what you see upstairs is that, given that int is a bool, right? Then it's a bool. Then that whole is of type of string or int of that Boolean value, right? Now, when you perform case split on it, then you have kind of used that dependency. So if you take a look at the type of these these new holes, you get to see that this one is now a string, and this one is an integer. Because in the previous situation, you had an assumption. You were taking something for granted that wasn't still established. Whereas right now, you can you have already established that assumption, and by doing so, you have made that assumption firm by you know, giving it one of the possible values. So now the book does it this way. I think this was like 94. And if my spelling is wrong, then you know the reason I am dyslexic. Now, so okay, this is our function now, up and ready. Now the next thing was that we were about to use the same thing in order to work out some sort of what is this called? The serialization, right? We would like to have some serialization. So, but our serialization here is dependently typed. Now, so here you get a Boolean which tells you whether or not you're working with strings or integers, and then you get something of that of the right type based on that Boolean, and then you return a string. Right now, you see the difference between this function and this function is that even though this is at the type level, this dependency of the type level is on the value of the first parameter, the return type of the function is no longer a type, it's a string, right? Now, so let's do our usual. Mikhail, could you please guide me through the TDD?
Press light bulb.
Yes.
I believe you add a clause.
Then?
Case split, I suppose.
Then you save.
Yeah, you save.
Okay. Now, case split and what?
On the
Is it too small? Let me try to make it larger.
On the is int.
Boolean, right?
Okay. So right, so the case split on is int, okay.
Wait.
Yeah.
Okay, then you do what?
Yeah, good question.
Then you save.
Yeah, you save, of
Okay.
course.
Can we see the types?
Now, sure. So let me. This is the one below. It says that provided that x is of type int, this whole is of type string, and this one says provided that x is a string, this one is of type string. Now this part of it might actually not be, you know, there's no much TDD going on hereafter, but so I'll take it from here. What the book says is that at this point it would like to use the function trim, which kind of, you know, does some trimming on the string, and then at this point it wants to cast. Well, maybe we should use the integer to a string. Now, the trouble here is that this function trim, I can't find it where it is. Right? It's I tried to find it and I failed.
I think it's only in Idris 1.
That is possible. The only thing is that I don't know then what the equivalent for it is in Idris 2. And
At a guess, data.string.
that might be just a moment. Well, let me. Yeah.
Hold on L.
Hold on L.
No, I think import works. Maybe try import instead.
Okay.
Hold on L works for me, I believe, but I might have imagined it.
Thank you very much indeed, James.
One of the language designers.
Thank you very much indeed.
When you've been a Haskell developer for as long as me.
Yes.
Yeah. Okay. But then, I mean, the thing is that I tried to find this in the language documentation, and I failed. So, and it wasn't on the page of the changes, updates of the book, from Idris 1 to Idris 2. So someone should go report that. Okay. What was it? Sorry.
Yeah, I believe I found it, but I need to. My window manager is making a fuss, so let me see.
Really?
Yeah, here, and if you Control F, then there is a trim function.
You are sending something to the text, to the. Let me try to see that.
Idris dash lang.
No, well, so you knew the answer and you went to look it up. That's a different one.
Actually, I duck gold trim Idris too.
Right. Okay. So you so let me try to understand what you did. You Googled for
Trim.
for trim Idris 2.
Mhm.
Okay. That's wise of you, and I was not as wise of that. So I what I did was that I looked up the Idris documentation provided online, and I used the automatic search, and the automatic search failed to find that.
All right. Fair.
So
Sorry.
thank you very much, guys, for being better than me.
No.
Right. Okay. So let's see. I think I have already told you all of these. Yes. Right. One important thing about type level function is that given that type level information is only available at compile time, and thereafter the type information gets erased, all the type level functions need to be total, right? Because if they are not, then something needs to be taken care of at the runtime for the lack of totality, right? So this is don't be surprised if you can't enforce partiality on these functions. So how many of you? This is a good time to ask for jokes. Let me see. I am going to ask James to go first.
Did you hear about the man that fell into the paper mill?
Man who fell into the paper
Mill.
Sorry,
Paper
mill.
Paper mill. Okay, no, I didn't.
Made the front pages.
Right. Yes. Okay. Good one. Yeah. Good point. Yeah. Jan, would you like to spare
Sure.
your one?
A Swedish farmer found a
sorry, sorry, Jan. Maybe you would like to leave that to later. Would you do you have another? No. Okay.
Oh no, I do. Yeah.
Oh, you do. Okay.
Yes. It's another Norwegian one. Yeah.
Okay, good. So we're not picking up on Swedes.
No, we're not picking on Swedes. Fair.
Okay.
We're not being nationalist. No. So would you like to hear a joke?
Yes.
I do.
Yes.
I do. Yes.
A chicken with a tie.
A chicken. Sorry, a chicken what?
Norwegian. Because vil du høre en vits? En høne med slips. And so you try.
So sorry. Could I have difficulty hearing you because the noise cancellation cancels.
Oh.
No, it's not on your side. It's not on your side. You know, Zoom. Sometimes when there are multiple people talking, it decides on just one of them to be heard, and so I had difficulty hearing you.
I see. So did you hear the setup? With the setup?
I heard it that you said that would you like to hear a joke, and we said yes, and thereafter
And then
you went on and off.
a hen with a tie. Because
Right.
because
Okay.
in Norwegian, this is another one of my translated jokes. In Norwegian, vill du høre en vits? En høne med slips rhymes. It's a very
Okay, I'm lost. I'm lost. So this is supposed to. So a hen with a
Tie.
what was it?
Tie.
A tie sounds like a joke.
Yeah, it sounds like a vits. Because it rhymes vits slips.
Okay.
I can do more English speaking jokes if you want.
I have
No,
some
that's
as well.
fine. That's fine. I did ask for these things. The first time that I told you that I would like to hear jokes. I said I would like to hear jokes which help me understand Norway better. So, okay. If someone speaks about hens and ties to me in the metro of a Norwegian city, I know that they're trying to joke.
Right up. Always trying to be informative.
Okay, very good. Now, James, you spoke about the man who fell in the paper mill. I around like maybe 6 years ago, there was this Iranian gentleman who was coming here for sabbatical from University of Tehran, and he told me about an occasion when he was a child. They had taken them to a sugar factory, and so they had asked they were explained about the different parts of the process of the sugar production, and at the very end, the gentleman who was touring them around had told them that sometimes strange things happen here. So, for example, once it happened that when we were producing our sugar, we realized that the sugar is all brown, even though we had done all the due diligence for making the sugar white. So as you know, there's extra processing that is required for the sugar to become white. And so he said that we did whatever search we could to make sure that the process was in order, and we were completely confused, and we couldn't figure that out for a few days, and all our sugar was being brown, until we at some point we decided that it's time to maybe clean some of the parts. And when we were cleaning the parts, we realized that at the very end of the pipeline, there has been a warhog that had
Oh no.
had felt inside from the top, and so all that brown thing that we were receiving was the blood of this animal,
Oh my God.
Oh no.
Yeah. So yes, this didn't make it to the front pages, but it made it to the sugar.
Oh.
Yeah. Luckily enough, they didn't sell this sugar because they, in Iran we actually don't consume brown sugar. And people would have not wanted to take it. But the guy gave me this he told me about this memory of his when I told him that I enjoy brown sugar, and I tried to be hospitable to him, offering some brown sugar, and he said that maybe not a good idea, because that might be the warhog. Right.
Oh.
Oh.
Yeah. Okay. Now, how many of you have done C programming? C and not C++, C. Okay. Okay. So are you familiar with this function printf?
Yeah.
Yeah.
So you probably know that printf works on the basis of certain flags that you slip in the string that you provide as a where you want to place what inside the string that you put on the screen, or on the, if that's an sprintf, then that would be a file. I mean, things of like. So these are labels, right? Now, have you ever, and I'm guessing the answer is yes, or I'm hoping that the answer is yes, have you ever been caught by trying to, for example, pass an integer where you were expecting, let's say, a string or a character? Have you ever experienced it? What happened? So Daniel, explain to me what happened when you mismatched the typing.
Oh, this is a while ago.
Oh, okay.
I believe it's still printed, but the formatting was off. But
That is correct. That is correct.
Yeah.
And can you explain the reason?
I'm guessing, who would try to interpret the value in the way I indicated, so why,
Okay. Now,
not too sure really.
that's fine. Niels, do you have an explanation for that which relates to types?
It's with C.
That's right. The printf of C, why does it accept let's say strings when it is expecting an integer, and it still produces something which is rubbish, by the way? Why does it do that? Can you explain that to me?
Is because it tries to read like the binary as a string, but it's not a string.
That's true. That's true. Now, can you tell me why that is not a compile error in C?
No, because I only get compile errors in C.
Right, and okay, and when you get them, can you explain them?
No, not really.
No, you can't. No, you can't. Okay, that doesn't that's not nonsensical. So I can accept that. Now, here is my last trial. Does anyone have any explanation for that which relates to type theory?
Yeah.
James has. Okay. Sorry, James. Your hand was up, but I because your picture is just so small, I had difficulty seeing your hand. Sorry. Go on.
Because the only difference between an int and a string is how the programming language deals with the same underlying bytes. And so your programming language is treating that integer as if it is a string. Printf is not typed. And so if your format string has a %s and you pass it an int, then it is going to treat that int as a string. There's no way that C can look at that the format string, and extract type information for it. So that's why it's not a compile error. And the reason you get rubbish is because it treats the int like a string, and so it just keeps reading until it finds a 0.
Right. Okay. That's a good explanation. Thank you. Now, there is a piece of terminology here that use for this type behavior. They say that printf is not type safe, right? Now, which means that, like C does not have enough information during the type checking so that it can enforce type safety, right? And type safety for someone like me who is who can only program or only likes to program in statically typed languages is a very important issue. You know, it's I essentially want to have as much type safety as possible, and there are various levels where you can put the bar, and I want it to be as high as possible. Now, here is something that is very, very nice with Idris. Now, given that Idris is a dependently typed language, typings of things can, as you have already seen in the previous examples, can depend on the values of other things. In this very case, we can utilize that dependency so that we depend the typing of printf on the values of those formatting labels, right? Now, the book goes through a series of engineering decisions so that it can kind of help you grow that mindset of how do you deal with these dependencies when you're designing. I am going to tell you, I'm going to teach you this very section on that matter, right? 6.2. There is another one which relates back to the data store. I'm not going to teach you that. That's a read it yourself, right? But in order to grow that mindset, especially in Idris, I highly recommend that you do read that section 6.3, which is the next one, right? That's a do-it-yourself. Now, here is something that I would like to explain very early. It's not in the book. It's a because you guys are very good, I'm sparing it. But usually this is beyond the level of my students, so I don't explain this much of it. Now, so we have been on and off speaking about dependently typed programming in Idris, and some imaginary, for the moment, correspondence between that and C++ template metaprogram, right? Now, I have always told you that there is a correspondence that we're going to explore. Before we get into that correspondence, I would like to warn you on something specific. Now, there is a company here in Belgium called Raincode that has a very niche business of translating dinosaur code into C#. So they are given code bases that are written in COBOL or PL1 or things of the like, that all the programmers of which are now dead or if not retired. And so the company that has been running that piece of code for decades now is now out of human resources who can maintain the code. Right? Now, what this clever company does is that it cross compiles that code base into C# and gives them back the C# code, because then there are loads of C# programmers out there in the market, right? Now, you understand that a part of that business is on ensuring that the original dinosaur language code base and the resulting C# have the same semantics, have the same kind of behavior, right? They technically they're said to be required to have observational equivalence. Now, this is a term that is very dear to me, right? Now, so there is a very nice presentation of that on a workshop that I ran for 2 years with a close colleague of mine called Paul Keir, who is from University of West of Scotland. The workshop is called Primal, the programming research in mainstream languages, right? Now, in the second edition of that, which was 2 years ago, the head of this company, Raincode, called Darius Blasbon, if I'm not mistaken, has this beautiful presentation of how they do this job, right? Because their developments are in C# and they are essentially doing applied language theory. Now, one of the most important and unexpected lessons that he brings up in that presentation is this. So he says that when I'm interviewing people, I get people who come from the background of PL theory, programming languages theory, and I ask them what is kind of your opinion about this cross compilation, and they say that's just like another compilation. You know, you work out the AST, the abstract syntax tree, and you traverse it in your target language, and that becomes the target code. It's just like if you're translating into assembly, you just performing compilation. And there is the point where he can catch those who don't fit, right? Because in cross compilation, that is not quite the case. In cross compilation, your target language has its own idioms and idiosyncrasies. And if you're producing a code base that you would like to hand over to your client, your code base better behave. It better be easily maintainable, right? And it has to go with the idioms and the customs of the target language. This is where it comes when it becomes different from the usual compilation. Now, this is his catch question. So if in the future you apply for his company, you know that how to get past that question. Now, why did I bring this up here? As we go through the C++ template metaprogramming, one instructed exercise that you might want to go through is to try to work out the examples of this book in C++ template metaprogramming. I haven't myself done that, right? However, because you guys have always been ahead of my teachings, I thought I should warn you with this, because if you want to do that, then certain things, if you do them if you just want to cross compile, well, this is not cross compilation. If you just want to port what is in the in this book into C++ template metaprogramming, you might end up producing C++ template metaprogramming that is not natural, that shows up as an anti-pattern, right? So be careful about that. Now, sorry if that was too much anticipation. In case you were not planning to do that, and my apologies for wasting your time. Now, let's get back to Idris. Now, so as a warm-up, the book starts by working out what is called a variadic function. So, and by the way, this is I don't think that the book itself mentions this term variadic, right? But variadic is a function that can accept a variable number of parameters, right? So printf, for example, is a variadic function, right? Now, one of the problems with the support for variadic functions in C is that it is not disciplined, right? Now, the typing of the individual arguments that you pass to a variadic function is one thing. The fact that the programmer cannot traverse that list of arguments that are sent to the function is another thing. Now, as we will go to C++, you will see that C++ templates have these support for variadic template parameters, but it's disciplined, it's regulated, right? And it has both things. It has, you can traverse through the list of the arguments, and you can introspect the individual types or values of the arguments passed to the variadic template. Now here because there is no internal language support for variadic functions, Edwin Brady is trying to show you how you can utilize the available support in Idris for dependent typing in order to simulate the situation. Now, how he does that is by doing this. He is going to tell us about a function called adder, which is variadic, and it takes one parameter, which is the number of, oh, maybe I should just make this larger. Yeah, okay. It takes one parameter, which is the number of parameters that it will take to add up together. So if you pass 0, it is not, and this is the additional arguments, the number of additional arguments. It's not expecting any additional arguments. Only the initial value is the only thing that it expects, right? Now, if you pass 1 in addition to the initial value, it is going to expect you to provide 1 additional argument. If you pass 2 in addition to the initial value, it is expecting 2 parameters to be passed, right? And so on and so forth, right? This is the way that you kind of simulate the business of what is it, of variadism, right? This is, I don't think variadism is a term. Well, support for variadic functions. So by trying to give this a type, you know that adder of 0 is a function from int to int, because it only is going to expect you the initial value. Adder of 1 is a function from int to int to int, because in addition to the initial value, it is expecting you 1 in additional argument, and so on and so forth, right? So you see that there is a dependency on these first items here. Now, we have already seen that there is a possibility for working out that these types based on the value of this guy, right? Because we are in a dependently typed language. Now, so here is how you can do that. You can first of all, work out the type of this function, right? This is not still the function itself, right? Now, the type of that function, well, first of all, this adder type thing, it takes a number of arguments, which is a natural, a nat, and it returns a type, right? Okay, now, if that number is 0, then the type is nat, sorry, is int, right? Now, if it is non-zero, which is k plus 1, let's say it's a successor of k, the type is an integer and then add a type of k. Okay, are we all good with that? Now,
Wait, one thing.
Tell me.
Why is it named like next? Wouldn't it just be int and then add a type k? Or is it no difference?
Well, that's I think that is simply for the for code reading, right? For readability of your code. But you are right in that this given name is not used in the rest of the typing information, right? So you could have, if you wanted to, you could have just written int arrow adder of k, because this name is not being used elsewhere.
Okay.
Right? However, it shows the intention better. So that's also the same about num-args, the number of arguments, right? It's a courtesy to the human reader of the code, right? Yeah. Thank you for the question. Now, so now that we have that type level function, we can now work out the typing of the adder function itself. And I am expecting a good wow at this point, right? Now, so the adder function itself, it takes a number of naturals. It takes an initial value that well, given that it's going to accumulate our addition, it's called ACK, right? And it's going to return something which is of type adder type of this numargs parameter, right? So you see this, type level calculation that we performed here is important because we needed to work out the return type of our adder, right? I would like to invite you to compare this typing with these guys here. I can't highlight two things, so please excuse me for only highlighting one of them. Right. Take your moment to work out your way through that. Are we all good? Does anyone need more time? No? Okay.
I'm good.
Yeah, very good. Now, so let's go do some TDD here. What listing is this? 864. Well, right. Maybe I should leave that for a bit later, because the listing is even more general. Oh no, maybe I don't know. I'll go by the book. So let's see. So if you perform the usual k-split, sorry, the usual TDD on this, then you will be producing a skeleton, and then you will k-split on numargs. And as you're doing that, there are two cases. There are Z, and there is Z, which is for 0, and there is a successor of K. And in those two cases, well, the first of them is pretty obvious. So if like in this case, if you are expecting, so if your adder is expecting 0 additional arguments, all it needs to do is to return the initial value, which in the code the book is referring to as the ACK. So that's what this one is doing. And now it remains to do this case. Now, if you take a look into the typing of, excuse me, if you take a look into the typing of this whole, right, you will get to see that it says, given that K is a natural and ACK is an integer, this whole needs to be a function that takes an integer and returns an adder type of K. And I'm going to repeat myself here. It returns an adder type of K, which means that it will return an instance of this type, adder type of K. It's not going to return the type itself, right? Now, in this case, the function adder type was returning a type, right? In this case, we are returning an instance of that type, right? They're different, okay? Now, so, okay, now we know that the second case is going to be a function. So here's our lambda expression. Now, what it returns is an adder of size of K additional arguments, with the ACK being next already, taken up into account in the ACK, right? So that's how our recursion works. Now, if you generalize this adder function so that instead of just working with integers, where is the right, just working with integers, given that you now know the operations that you're gonna perform, right? You can say that, okay, I want to have I want to work with adders who can perform the same job for every num type that is of the interface nom. Right now, let's see this in TDD in action. Where have I put that? Okay, so now with the generalization, our adder type is no longer going to be on integers. It will be a function that receives a number of arguments, which is natural, a type, which can be int or it can be other things, but it needs not to be int specifically, and it will return a type. Now, let's see. Who has not given us a TDD thus far? Right, Jan, go on.
Right. I guess we do the introduction, or yes, split the signature at close.
Okay, we can go for that, or we can in fact
Generate some
yeah,
definitions here, can't we?
I'm going to give you a clue. You can always have your cheats down here.
Mhm. Yeah, yeah.
We have to
I guess
constrain it.
Hmm?
Oh, never mind.
Okay.
I would say do yeah, do the first one. Generate definition one.
Okay.
Split on the
Then you save.
Then you save, yeah, then you save. Emacs
Okay.
saves
Now,
timing.
what do we split on then?
The namag.
Okay.
Yeah, yeah.
Wait. Sorry. Wait a moment. I'm not seeing that bulb thing.
Hmm. Is it saved?
It
It
is
saves.
saved.
Hmm.
Is that because no, I'm not. Okay.
Oh, there we
Now
go.
it's here. Yeah, okay. Okay. But it's not
Huh.
splitting anything. So if I do add clause, it's just another
Okay.
of those.
That's interesting.
Yeah.
So maybe yeah, maybe if you add a question mark on the other side, and then since it's not total, it's not confused.
Right. I think the thing is that okay, let me do something else. I think I can help on that. You see, let's say that we add clause
and then split.
What is
Okay,
happening?
interesting.
What's happening? Something is
It is an instantiator, so
okay.
and then
Now
split.
save. Then we should be able to case split. Okay. You see, I think what was happening was that because we had already made our mind with the case split of namag, right? We had already chosen not to split, essentially, right? We no longer had that chance. I think that's what was going on.
Probably.
Okay. Right.
Okay.
Now, okay, what
going.
next?
No, it can't give you. I think you have to just fill in num type there. That would do.
Well, let's see.
Well, we can try.
Okay.
Oh, will it just no? It could give it added like X, since it's in the context. So
yes,
good check.
that's right. So I would expect it to be able to do that. Yes, it is.
It is, yes.
Yeah.
And then here it should be
this one is, you know, this is I don't think that it can do a lot.
Can it introduce
let's see.
Let's see
whether it can do anything.
It can do added type KX there, but
okay.
one below. And then I guess
still a type. You see,
yeah.
So X itself is a type, and it has only promised to return a type. So X is an option.
Can just return X. Yeah, of course.
Yes. And the type of K and X is also a type. So that can be an option.
But it's not quite.
So anyway, yeah. The point is that the search space is quite huge, and there is not a lot of sensible information around that can help the automatic decision making, right? So okay, now you have your cheats down in the
Below
in the
the comment.
comment part. Yes. But now that we have not bothered to rename things, that would be add a type. I hate these parentheses that it gives us. Okay. And
Num type, but you have an X in your lambda. So it would shadow the X. That's
okay, very good.
Okay.
So let's
That
rename that.
next.
Let's
Or Y. Or
yeah,
Y.
okay.
Yeah. And
Right,
then
yeah, okay.
X.
And what?
X, since that's the num type.
Very good. Very good.
Mm.
Now, what do you think is the trouble with that? Why?
It doesn't know what type it is. Doesn't know what it knows that it's a type, but it doesn't know that it's a num type or whatever sort of thing you'd like.
Okay, I'll give you another chance. Take a look at the error message.
Well, if it's an undefined name.
So we have introduced a new name here called Y. We haven't said what that thing is.
Yeah, so they can't infer that. That's
right.
what I was trying
Indeed
to
so.
say. Yeah.
Indeed so. Now, what do you like to put here?
Colon X.
No.
No.
Colon X. Like this?
Oh no, I mean Y colon X.
Well,
since X is a type variable, you want it to be of the same type, and then wrap it in brackets.
Okay, wrap it in brackets. Okay. Now, if it would have been that we didn't want to name this variable Y, how would you put it then?
Underscore.
That's one possibility, yes. Okay. What else?
2 underscores. Oh gosh, sorry, the screen went blank.
2 underscores. Do you mean like underscore?
No, I don't think it. No, I don't think.
Underscore.
Yeah, but I don't think it could infer that. I don't think it could infer num type at that point, so I doubt it.
Oh, let me try that.
I don't think so. Yeah, it can't because it's too general. It could confused.
Okay.
Unified.
Right. Now, what else would you think that we can put here? Try to see whether. Right. Let's see. I'm gonna try something for you. So let's say that we had put this, right? Let's see whether it has any quick fixes available. Okay.
No.
Okay. Fine. Does anyone have any simple solution to that? I am right, James.
X.
That's right. So
you could just put X. Yeah, true.
Correct. So what we had written was that I'm going to take a Y of type X. Right? Now, given that we're not using this Y, right? We can simply just say, I want to take a variable of type X. Right? Now, one thing I would like to draw your attention to is the fact that with these names not being very suggestive, it's very easy to get lost, right? So that's why the book keeps pushing for good names. It's actually an excellent software software development piece of advice, that you should try to give your software engineering, that you should try to give your variables good names. Otherwise, you get lost very quickly. Now, Daniel, I have the impression that you are a bit lost. Is that correct? Okay. Would you like to point me? No, you're good.
I'm good now.
Okay.
No, it was what you were saying with well, now it's num type. Or it being X before was very easy. It was very quickly getting lost.
Right.
In what the expressions were saying.
Right. Okay. Now then, so let's do the adder function itself. James, would you please guide me through the TDD?
Yeah. So I think we should add a clause.
Okay.
So light bulb.
Yep.
And then save.
Very good. Yeah.
And then we'll case split on num args.
Okay.
And then save. And then we'll see if there's any proofs for that, for what you have highlighted. Any?
Okay.
Yeah. Let's click on that light bulb. Oh no! I mean, it should be X, but it should be able to work that out.
Expression search.
Oh yes, there we go. That was good.
Okay.
Lovely. Save.
Right.
And then
save.
We can have a look at the proofs for the adder right-hand side one.
Well, it's always a good idea to take a look at the typing information that is available. It will somehow, it will help us, the human beings, to put ourselves into the shoes of the compiler. So we know that in this case, for example, we know that there is a num type, which is a compile time piece of information, because the multiplicity of that is 0, which is of type, right? We know that there is, given a k, which is a natural, and given an x, which is of num type, which is this num type up here, the compiler can draw the conclusion that the whole is of type this function, right? So it knows that this is a function. So it might be able to at least work out some of the details of a function for us.
Yeah.
Okay.
Shall we? Do you think it'll do any useful? I don't think it's going to do anything useful here, but we can have a look.
Right.
I can intro a lambda.
Yeah. That's a useful thing.
Very good. And you see, it has given the name next to this. Where do you think this name comes from?
It comes from the adder type.
That's right, from line 3 of the adder type. That's right. So getting back to Daniel's question,
okay,
right? It's the Idris compiler is quite smart on the namings, right? It can utilize the naming pieces of information that you give it. When you at the type level name your type level argument certain things, it will try to mimic that at the value level, right?
Yeah.
So not just human readability, like I said before, there's also some level of cleverness at the compiler level too, right? Okay, James, would you mind continuing, please?
Sure. Let's see if it has anything to say about that.
Okay.
I don't think it will.
Okay.
But I see. No,
it has a lemma. It has 2 holes. None of them are really useful. Okay.
Well, it's going to be a recursive call to adder.
Right.
Okay. And then, yep. And then numargs becomes K.
Okay.
Will
Would
it?
you like to see whether
Oh,
it
yeah.
has anything?
Oh, there
It
we
does.
go. Yeah.
Mm.
It
Yeah.
does.
Why do you
Very
think
nice.
that is the case?
Well, it's worked out from the type that bracketed part has to be. I mean, it's done type inference to work out that numargs.
That is true. That is true. And it's trying to use the contextual information.
Yeah.
Right. So in this context, you know, we know that the first argument to adder is a nat, right? And what nats are available in this context? Well, we've already used S of K, so most likely it's going to be K now, right? Yeah. So that's how it can figure out this one. Okay, saving.
And then we'll have a look. I've got higher hopes now.
Okay, very good.
Ah, no. Oh well. It's X plus next.
Well,
Oh,
okay.
I can't see that one.
I can't either. But
Let's see what it is.
place our bets. No, this is not good.
Oh,
Okay.
try again.
Yeah.
Hmm.
Ah,
No.
But you see, these are both very sensible choices. If
Yes.
the only available piece of information is what the compiler has.
Yeah.
Right? Because both X and next are of the type of the right type. Right? Now, what the poor compiler can't figure out is that, oh, it's true, both of them are of the correct types, but what we want is the addition. That is your semantics, you know, that the compiler can do mechanical reasoning for you, but it can't do the semantics that is in your logic. Right? It can unfold it for you, and if through that unfolding it comes to the point where there are only very little number of options, it can hopefully make a clever choice. But that's only when the search space is very narrow. Right? Now, okay. What did we want to put here? We wanted to put next plus. Oh, let me just get rid of this one.
X plus X.
Okay. Here is our function.
Lovely.
Now again, I would like to draw your attention to the fact that you know, you might want to give these better names. Right? So like this is the books version, right? The books version speaks about the accumulator in the proper names. You know, it gives the name ACK to it, so that you know that this is not just a random variable, it has semantics attached to it. Right. Okay. Now let me stop. Any questions? No. Okay. Now I'm going to stop the sharing. And I am also going to stop the recording.